بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Welcome my dear students in the third preparatory grade. We will complete the lastest part of the first lesson in المعاصر book. Okay. Problems. A runner covers 450 meters in 45 seconds. Okay. Find his speed. The speed equals the distance over time. Distance equals 450 divided 45, so it's equal 10. When the measuring unit of the distance is meter and the measuring unit of the time is second, so the measuring unit of the speed is meter per second. This is the first question. Question number 3. A train covers 50 meters in 2 seconds. Okay, 50 meters, this is the distance, and in 2 seconds this is the time. Find its speed in kilometer per hour. At the first, we can calculate the speed by meter per second. So the speed equals distance over time. It's equal the distance 50, okay, divided 2, it's equal 25 meter per second. When we convert from meter per second to kilometer per hour, we can multiply this number. It's 25 times 18 divided 5, okay. Divided 5 equal 1, divided 5 equals 5. 5 times 18, okay, 5 divided, 5 times 18, it's equal 90. So the speed equals 90 kilometer per hour. Okay, question number 4. A train starts to move at 7 o'clock in the morning. Then what is the time of arrival if it moves at a speed of 100 km per hour to cover the distance of 500 km? This is the speed by kilometer per hour, and this is the distance by kilometer. We will find the time. Time equals displacement or distance over speed. Okay, the distance equals 500. Divided the speed equals 100. It's equal 5. 5 what? The time. The measuring unit of the distance is kilometer and the measuring unit of the speed is kilometer per hour. So the time is calculated by hour. This train starts to move at 7 o'clock. So it reaches after 5 hours. So it will reach by 7 plus 5 equals 12. So it will reach at 12 o'clock. Okay. The following question. Question number 5. Okay. A bus covers a distance of 120 kilometers. This is the distance. At a speed of 90 kilometers per hour. This is the speed. Then it covers 105 kilometers. This is a distance at 70 kilometers per hour. Calculate the time needed to cover the whole distance. We should calculate the time at the first part of this journey, okay? Then we can calculate also the time in the second part of this journey. A bus covers a distance and the speed. We can calculate the time. Time equals distance divided speed. It's equal. The distance equal 120 divided the speed. It's equal 90. Okay, 12 divided 90. Divided 90. It's equal. Okay, it's equal 0.13. 0.13 kilometer. No, this is the time, it's hour. Okay, the second part of the journey, we can calculate the time. Time equals distance over speed. It's equal this distance equals 105 divided the speed, it's equal 70. We can calculate the time by dividing 105 divided 70, okay, it's equal 1.5 hour. It needs the time needed to cover the whole distance. So the time equals time 1 plus time 2, it's equal 1.3 plus 1.5, it's equal 2.8 hours. This is the answer. We calculate question number 8. We answer 7, okay. We will answer question 8. A body moves at a regular speed, okay. According to the following mathematical equation, d equals 60. Find the speed of this body. The speed equals distance over time. Okay. When we calculate the distance, I didn't find the value of d, but I find its value by t, depends on t. We can apply by t by 6t, okay, divided t. Is equal displacement or distance over time, and the distance is applied by 60, okay. So distance equals 60, okay, and this is the t. Time with this time, okay. So the speed equals 6 what? Meter per second or kilometer per hour. The following question and the same question, but he said the regular speed by meter per second, so we will remove kilometer per hour. The second part, the time needed to cover 360 meters. It need time, okay, and we give this problem give the distance, okay. I have a distance, I need time, and I calculate its speed. So the time equal distance over speed. Distance equal 360, okay, and the speed equals 6. So the time is 60 what? Second, because we measure the unit or the distance by meter, so the time is second, because that's the speed by meter per second, okay. The following question, we will answer 9. Study the following figure. Then answer the following. A body moves from a starting point 8, A. This is the starting point to ending point D, okay. It covers this distance. Add the showing distances and the time in the figure, okay. From A to B, 5 meters. From B to C, 4 meters. From C to D, 1 meter. The time from A to B, 2 seconds. This is the time. From B to C, this is the time, 2 seconds. And from C to D, 2 seconds. Okay. Does this body move at regular or irregular speed? To know this type of this speed, we will calculate the speed in each period, okay? In the first period, AB, the speed equal 5/2, distance over time, okay? 5/2, the speed equal 2.5 meter per second. This is the first period, the period A. At the second period, from B to C, the distance which is covered by the object equals 4, okay, 4 meters, and the time equals 2, so the speed equal 4/2, okay, 4/2. So the speed equals 2 meters per second. Distance over time, 4 divided 2 equal 2 meters per second. And the third part of the shape, okay, or the figure, the distance is 1 meter and the time is 2, so the speed equal distance over time 1/2, it's equal half, 0.5 meter per second. Okay, this speeds are different, so this speed is irregular speed. Okay, why? Because it covers unequal distances during equal time. We should know the time is equals and the distances are different. So this object moves by irregular speed or ununiform speed. Okay, at the first period equal to 0.5, the second period 2 meters per second, and the third part or the lastest part equals 0.5 meter per second. We will answer question number 11. Okay, question number 11. Calculate the average speed for a car that moves in a circular path whose length is 300 meters for 10 rounds in 3 minutes. Okay, I need average speed, so I will calculate the total distance divided total time. Speed equal total distance average speed, okay, v dash, total distance divided total time. Okay, this object moves to form a circular path. Circular path, its perimeter equals 300 meters. Okay, this a circular or the circle, this perimeter, okay, it's equals 300 meters to form one circle, but it form 10 rounds. 10 rounds. So the distance or the total distance equal 300 times 10. It form 10 circles. Each circle, its perimeter equals to 300. So the distance which is covered by this object equals 300 times 10. It's equal 3000, okay? Then the time in 3 minutes. 3 minutes, it's meaning that 3 times 60 and convert from minute to seconds, okay? It's equal 0 with 0, 300 divided 3 times 6 equals 18. We will calculate it. 300 divided 18 equals 16.7 equals 16.7 what we measure the or calculate the speed. Its measuring unit is meter per second. Okay, the following question number 13. Okay, a moving car A in a straight line measure the relative speed of a car B. So car A, okay, observe car B which was moving in the opposite direction. So car A in opposite direction with car B. It found that the relative speed of the car B was 140 kilometers. This is the relative speed. Okay. When the car A reduces its speed to half, okay, it found that the relative speed of car A becomes 100 kilometers. Car A reduce its speed, okay, the observer speed become half. Observer become half. It found that the relative speed of the car B becomes 100 kilometers per hour. So the relative speed, another relative speed equals 100 kilometers per hour. This is a relative speed also, okay? Relative speed of the car B, but at the second part of this journey, okay? Calculate the real speed of the two cars. Real speed, we need the real speed of car A and the car B, okay? Okay, the first part, determine the relative speed. Relative speed equals, okay, equals 140. In this part, the observer in opposite direction with the car A, okay, car A in opposite direction with car B, okay. Then relative speed equal real speed of car B minus or plus, okay. Relative speed equal real speed plus V of observer. The second part talk about the car A, okay. Car A is an observer, so the relative speed become 100 when the V of observer become half. So the observer velocity it's equal half VO, okay, plus half VO. Real speed of car B doesn't change. So the real speed B doesn't change. Again, the car A moves at the first part by a velocity. I don't know this velocity. I called it VO. And the second car is car B. This is car A. This is car B. In opposite direction. The car B doesn't change its velocity. Okay? Real speed of the car B doesn't change. And the first part, the relative speed equal 140 when the observer has velocity VO and the real speed equal B. Okay. the second part, when the velocity of the observer become half, the relative speed changes. It changes to 100 km per hour. I need the velocity O of car A and the velocity of car B. I find this value doesn't change, but the change in relative speed and the velocity of car A. Okay, then real speed B, they are equals. I'll be equals these values. Okay, real speed from this law, real speed equals 140 minus VO. Okay, plus minus VO. I put VO at the second side. VO plus, I form it by negative. Okay, real speed of car B equals 140 minus VO. Okay, the real speed of this law, okay, equals 100 minus VO. Real speed, the same real speed of car B equals 100 minus half VO. Real speed equals 100 minus half VO. This real speed, the speed of car B, equal the speed of car B. It doesn't change, okay? We will equals these values, okay? 140 minus VO equals 100 minus half VO. I have unknown only, one unknown, it's VO. This is the velocity of car A, okay? Then I form negative VO at the second side. We form it, it's here by negative. I put it by positive. So 140 equals negative VO. We form it by positive VO, okay? Minus half VO, and form 100 by negative. It's by positive. I form it at the second side by positive, by negative charge. It form minus 100. Okay, 140 minus 100. It's equal 40. Equals VO minus half VO. It's equal half VO. VO equals, then VO equals half. I form it at the second side. It's equal 2 times 40. So VO equals 80 kilometer per hour. So the velocity of the first car A, the first velocity of car A, it's equal 80 watt kilometer per hour. And the second car, car B, okay? We can apply in this law, okay? Real speed of car B equals 140 minus 80 VA, which is VO, okay? 140 minus 80, which we calculated, it's equal 60 watt kilometer per hour. We will achieve if we are correct or wrong, okay? At the first, relative speed was 140. 140 equals the first car B, the car B, its velocity equals 60. 60 plus what? Plus VO, which equals 80 when we calculate it by 80. Yes, 80 plus 60 equal 140. At the second part, the relative speed was 100 equal. The real speed of car B doesn't change. It's equal 60, okay? Plus half VO. Half VA. VA was 80 and its half equals 40. Yes, 100 equals 60 plus 40. Okay, that's right. To another page, and we will answer, questions. Question number 18. Okay, we will choose many of these questions. Question 18. A body on a bike, okay, covers 300 meters in a minute and 420 meters in the following minute. Calculate his average speed during the first minute, second minute, and 2 minutes together. We can calculate it very easy, okay? The first, we can calculate the speed, first minute. It covers, this bike covers 300 meters. This is the distance. The first distance 1, okay? In a minute, this the time. It's called the T1. So in the first minute, it's equal the speed of the first minute. It's equals D1 over T1. It's equal distance equal 300 divided minute. We can convert it to seconds, okay, by 60. 0 is 0, it's equal 5. 5 what? Meter per second. This is the first minute speed, okay? The second minute speed. Second minute speed, the second distance, it's equal 420. 420 divided in the following minute. So it take or covers this distance during 1 minute. So I will convert it to seconds. I'll multiply by 60. 0 is 0. It's equal 7. 7 what? Meter per second. 2 minutes together. 2 minutes together, we can calculate the average speed, V dash. It's equal total distances divided total time. Total distances, it's equal 300 plus 420. It's equal 720. Divided 2 minutes, 2 times 60. Okay, 0 is 0. Divided 6 equal 1. Divided 6 equal 7. Now, it equals 12, I'm sorry. 12 divided 2, it's equal 6 meter per second. This is the average speed during 2 minutes. Okay. Question number 21. Okay. A racer ends the race in 2 hours with average speed 25 km per hour. If you know that the racer covers the first 15 km in an hour, calculate the speed of the racer after the first hour to complete the race in the given time. Okay, a racer ends the race in 2 hours. Okay, the total time equals 2 hours. And its speed equals 25 km per hour. This is the average speed, okay? Average speed. If you know that the racer covers the first 15 km, okay? All the race has a distance. This distance equals 25 km. He covers the first 15 km. 15 km, okay? 15 km. The remaining it's 10 km, okay? The first 15 km, it take it, okay, or form it during in an hour. 15 km during 1 hour. Okay, calculate the speed of the racer after the first hour to complete the race in the given time. We should know the second part of this race, okay? It take 1 hour. Why? Because it take the race, all the race, during 2 hours. The first 15 km it take 1 hour. And the second part, 10 km during 1 hour. So I calculate the race after first hour by dividing the distance divided time. The distance it's equals 10. 10 divided time equals 1. So the speed is 10 km per hour. Okay. Question number 24. 24, okay? A racer covered a distance of 100 meters of a straight track in 10 seconds. I have a distance and the time, we can calculate the speed. Then he returned back walking. He took 80 seconds. Okay, he covered the same distance, 100 meters, during 80 seconds. This is the same distance which is taken by the racer during move, okay, in this during running in this race, and he returns back walking, okay, walking. So it take more time. At the first, he take 10 seconds. Because he is running, but when he returned back, okay, it take 80 seconds, the same distance. to come back to in a straight point, okay, of running. Calculate the racer average speed. We need the average speed while running. While running, it covers 100 meters during 10 seconds, okay, 0 is 0. Its speed equal, his speed equal 10 meters per second. The second part, okay, while returning, it covers the same distance, which is 100 meter, okay, which are 100 meter. Then the time, it's equals 80 seconds, okay, we can calculate it. 100 divided 80, it's equals, okay, 1.25. 1.25 meter per second. This is the speed, and this is the speed, okay? We need the average speed. During the whole trip, it's equal total distances during the total time, okay? The total distance 100 during he go back or during the running, and then returns back the same 100 during its walking, he walking, okay? The total distance equals 200. 100 plus 100 divided the total time. The first time is 10 and the second time is 80, so the total time it's equal 90. So when we calculate the speed, it's equal 200 divided 90 equals 2.2 meter per second, okay? Question number 27. Calculate the actual speed to the car whose relative speed is 130 km per hour relative to an observer moving in the same direction at a speed of 50 km per hour. Again, calculate the actual speed, okay? The car whose relative speed, so I have relative speed. This is relative speed, okay? Relative to an observer moving in the same direction. I should know the car, okay, or the car move in this direction and the observer in the same direction, okay? The speed of the observer at speed 50 km per hour. This is the observer speed of observer. I know the relative speed equal, when the car move in the same direction with the observer, it's equal real speed, okay, minus observer speed, okay. The relative speed, it's equal 130 equals real speed. I need real speed, and the observer speed, it's equal 50, okay. Relative speed equals real or actual speed, they are same, minus observer speed. Relative speed equals 130 equals real speed, I need real speed, minus observer speed, it's equal 50, okay. So real speed equal, I put 50 minus 50 at the second side, so it's 130 plus 50, it's equal real speed. So real speed equals 180 kilometer per hour, okay. The following question, or question number 30. Two trains move parallel to each other but in the opposite direction, okay. So they are in opposite direction, okay. The speed of the first train is 60 km per hour and the speed of the second train is 90 km per hour. Calculate the relative speed in the first that is observed by passenger in the second train, okay. Two trains in opposite direction, okay. First train 60 km, the second train, okay, opposite direction. We form the summation of the speed of the first train and the second train. So the relative speed equals 60 plus 90, it's equal 150 km per hour, okay. We will answer question number 31, okay, the last question. Two race cars, okay. The first car moves at a speed of 80 kilometers per hour, while the second car moves at a speed of 120 kilometers per hour in the same direction. Mention the following: the relative speed of the first car relative to observer standing on one side, standing the observer in a static state. So the real speed equal the observer or relative speed. Relative speed equal actual speed or real speed. I need the relative speed of the first car. The first car moves at speed 80 kilometers. So relative to an observer standing in a static state, so the real speed equal relative speed. It's equal 80 kilometers per hour. Okay. The second question. The relative speed of the second car which moves by speed equal 120 kilometers per hour, okay, relative to a passenger in the first car, relative to passenger in the first car. So the car, the same car, okay. Two cars move in the same direction or in opposite direction? In same direction, okay. So relative speed equal the real speed minus observer speed. Okay, the real speed is the second car relative to the first car. يبقى 120 minus 80, it's equal 120 minus 80, it's equal 40. 40 what? Kilometer per hour. Thanks for your watching. السلام عليكم ورحمة الله وبركاته.